All right, welcome to our second lesson for solutions. This lesson deals with concentrations. So concentrations are a measure of how much solute you have per solvent. Assuming beakers A and B, here's an image, assuming beakers A and beakers B have the same amount of solvent in them, which one would have the higher concentration? Well, beaker A is two sugar cubes, and beaker B only has one sugar cube, so we would say that beaker A has twice the concentration as beaker B. It has twice as much solute per solvent as beaker B. In chemistry, we use a lot of different methods to describe the strength of our solutions. Not just chemistry, actually. We use some of these in the real world, some of them in chemistry, some of them in our food ingredients and our additives. So you'll see a lot of these, and we're going to work with all of them in this class. You'll notice up here, concentration is a measure of solute per solvent or solution. Make sure you're reading and make sure you're familiar with these different types of units. So some of them say solution, some of them say solvent. So kind of be aware of that. It would certainly be helpful for you to study and know this chart. Generally though, it's not that bad. You're going to figure it out, I think, pretty intuitively. I'll try to point out the parts of it that might be a little more confusing than other parts. So in chemistry, we prefer molarity. The everyday world, so here's molarity. The everyday world tends to use mass by volume or percent by volume. So you're going to need both. Again, you're going to figure these out pretty quickly as you're working. Watch your units. So again, percent by mass is usually going to be listed as a percent grams over grams. So that one will be pretty easy to figure out. You need a mass over a mass. Percent by volume, again, you're probably guessing here, we're going to use a percentage sign, and we'll probably be working with milliliters over milliliters. Again, watch the terminology here, solution. The solution is more than just the solvent. We'll discuss that. I'll show you a couple of example problems here on the next slide, but again, be aware of that. So the solution is more than just the solvent. Chemistry, we like to use molarity. Molarity is symbolized with a big M, and it stands for moles of solute over liters of solution. You can probably tell why the real world doesn't use it much, as they're looking at moles, and moles is definitely a chemistry term. But in chemistry, we'll oftentimes use moles over liters. We'll also use molality, which, similar to molarity, molality is moles of solute over kilograms of solvent. And there's our different unit. We're not looking at our kilograms of solution here, we're looking at our kilograms of solvent. The symbol for molality is an italicized M. Now, I'm not great at drawing it sideways, drawing it italicized. If you see it in print, again, it'll be more italicized. If you want to symbolize that it's italicized, you can always draw a line under it, like I just did there. Now we have an italicized lowercase m. And then finally, mole fraction. We worked with this one in gas law. It's moles of solute over your total amount of moles. So add together your moles of solute and your moles of solvent. As far as a unit for this one, I'm not sure that we necessarily have one. Oftentimes you're going to see the question ask for X. Let's say you're looking for moles of oxygen, you'd say XO2. What's the mole fraction of oxygen? And this is actually not an X, it's Greek letter chi. So that's oftentimes what you'll see with mole fractions. Again, the actual unit itself, I'm not sure if there is one. All right, let's take a look at an example. So in order to maintain a sodium chloride concentration similar to the ocean water, an aquarium must contain 3.6 grams of sodium chloride per 100 grams of water. What is the percent by mass of sodium chloride in the solution? All right. Percent by mass is our solute, would be sodium chloride, over grams of solution. Again, that's an important concept right there. Grams of solution, not just the grams of water, which would be the solvent. So that's what we want. We have our 3.6 grams of NaCl, that's our solute, and we can very easily solve for our grams of solution. It's just 100 grams of water plus the 3.6 grams of sodium chloride. But make sure you're doing that part. Again, the solution is both the solvent and the solute, so watch out for that. Multiply it by 100% because we want a percentage and not a decimal. With appropriate sig figs, 3.5% sodium chloride solution. Let's take a look at another example. A 100.5 milliliter IV solution contains 5.10 grams of glucose. What is the molarity of this solution? Again, it helps to remember, think about it. What is molarity? It's moles over liters. We have 5.1 grams of glucose. Let's go ahead and start with that. And we have 100.5 milliliters of a solution. Now there's two things we need to do. We need to convert grams on top into moles, and we need to convert milliliters of solution bottom into liters. Again, milliliters won't work here. Molarity is moles over liters. So I went ahead and started with the top. It's not important which way you start. You could have started with the bottom or the top. Either one works. I added up 6 carbons, 12 hydrogens, and 6 oxygens, and I got 180.156 grams of glucose per mole of glucose. Then the bottom step, again, I need to go from milliliters of solution to liters of solution. Crunch the numbers, and we get a molarity of 0.282. Again, we use that big M to symbolize molarity. And that describes a concentration for us in chemistry. Hey, looking at another example. In the lab, a student adds 4.5 grams of sodium chloride to 100 grams of water. Calculate the molality of the solution. And make sure you guys are reading the questions, watching out. This is not molarity. It's close, it's similar, but it's molality of solution. So again, if you need to reference that chart, that 14.3 chart from a couple slides ago, feel free to do that. But you're going to want to be aware of the fact that molality is moles of solute over kilograms of solvent. Okay, we have 4.5 grams of sodium chloride from the question and 100 grams of water. Again, this time we're not adding in our 4.5 grams of sodium chloride. We don't want the solution, we just want the solvent. One of the differences when you work with molality. We need to convert grams to moles, so we'll start with that. Sodium chloride has a molar mass of 58.443 grams. And then we need to convert grams to kilograms on bottom. Grams of water to kilograms. We can crunch the numbers and end up with appropriate significant digits. We're limited to 2 because of that 4.5 grams sodium chloride. 0.77 molal. Again, it's a italicized M. And one more example, if the mole fraction of sulfuric acid in an aqueous solution is 0.325, again, notice the lack of unit, what is the percent by mass of the acid? Oh boy, what is this one asking? Kind of a backwards question, makes you think a little bit. What is the percent by mass? The question comes at the end, they give us information at the beginning. So percent by mass is grams over grams. Again, now we're back to solution. They gave us a mole fraction. So 0.325 moles of sulfuric acid over a mole of solution. We can easily go from 0.325 to over 1. Go ahead and convert our moles of acid into grams of acid. Next up, we have to kind of think through our project here. We're looking at 0.325 moles of acid. Here's the molar mass of acid. Plus, we know that the rest of the solution, so the whole solution is 1 mole. If 0.325 of that mole is acid, the 0.675, the remaining portion of that mole, will be water. And the molar mass of water is 18.015 grams per mole. So if we add those two values up, we now have a molar mass for our solution. We can plug that in then, and we can take our moles of solution into grams. Multiply the whole thing by 100%. 3 significant digits in 0.325. So we finish with 3 significant digits and our 72.4%. And that one was a little tricky. Had to think through the fact that a solution is going to be made up of both the acid and the water, the solvent. Homework for tonight. I think the dates on this are wrong. I believe Monday is January the 28th and Tuesday is January the 29th. So we're off by a day. Also, fix that, I suppose. One of these days I'll get excellence at writing on the computer screen here. Also, we are in Unit 12. This is the second homework in Unit 12. All right. Good luck.